All right, I know I'm probably going to forget, but I will try to say what the answer is to each question first so that if you get it right and you didn't guess, that you can move ahead. So the answer for number 1 is choice C. So if you got that, skip ahead, go to number 2. All right, so I'm just going to integrate this. So I am going to get, let's see, oops, maybe I should be on my little pen thingy here and I'll be okay. So I have 1/2, so 1/2 x to the 4th, right? Because that's going to be x to the 4th, and then I'm going to divide by 4, and 2/4 reduces to 1/2. Okay, plus 3x, and then I'm going to evaluate this from 0 to 2. So let's plug in the 2 first. So I have 1/2 times 2 to the 4th plus 3 times 2. Okay, once I get that, I'm going to subtract, plugging in 0. Now, I think that you can see that if I plug in 0, I'll just get 0. So then I'm just going to work the rest of this out. So 1/2 2 to the 4th, that's going to give me 8 plus 6, which is 14, which is choice C. So they give you dy dx, and they are saying the slope field for the differential equation dy dx equals blah, blah, blah will have vertical segments. Now, vertical segments means that your little slashy things would go like that if you were doing a slope field, right? So wouldn't that mean that you would have undefined slopes? And isn't this slope? And that will be undefined when the denominator is equal to 0, right? Undefined means denominator equals 0. So I'm going to take xy plus 5x, and I'm going to set that equal to 0. Oops, I forgot to tell you. The answer is choice E. So if you got that and you didn't guess, move on to number 3. All right, so anyway, so from here I'm just going to factor out the x. I'm going to get y plus 5 equals 0. A little t-chart here. So I know that x has to equal 0 or y has to equal -5. And if you look at that, that is choice E. The answer for number 3 is choice B, as in boy. So you can skip ahead if you got that and you did not guess. Okay, now for this question, it's really the intermediate value theorem. You don't need to know that that's what it's called. I think the easiest way to do this question, honestly, is just to sketch a little graph. So 1, 2, 3, 4, 5, 1, 2, 3. So they give you the point -5, 3. And then they also give you the point -1, -2. So we have those 2 points, right? And they're saying that f is a continuous function and it passes through those 2 points. So now, let's just look at this part right here. It says if the function is equal to 0. So that means the function that connects this point to this point has to hit the x-axis for one and only one value of x. Okay, so in other words, it's going to hit it once. Now, we don't know if this is linear. We don't know if maybe it curves up a little bit and does a little fancy stuff and then comes down like that. But it doesn't really matter. It only hits it once. Then which of the following could be the x value? Well, wouldn't your x value have to be somewhere between -5 and -1? Okay, so let me just kind of sketch this out for you. So perhaps maybe it is linear and it just goes like that, okay? Or maybe it kind of does a little fancy thing like that, okay? Or, I mean, the list goes on and on here, but, you know, maybe it goes like this. But any of those values, if you look, whether I'm here, here, or here, those x values are between -5 and -1. So then if you look here, the only answer choice that has an x value that's between -5 and -1 is choice B, which is -2. All right, number 4, really, you're just finding the derivative, but 4 times. There's kind of no easy way around this one. The answer is choice C. So I'm going to just start by taking the first derivative. And when I do that, I'm going to do chain rules. So I've got 4 times 2 plus 3x. That's going to be raised to the 3rd power. And then the derivative of the inside, which is 3. Now I'd probably simplify that. So that's going to be 12 times 2 plus 3x. and that's going to be raised to the third power. Now you're going to start to see something happen on this derivative right here. So let's take the second derivative. So I'm going to do chain rule again. So that's 12 times 3, which is 36, times 2 plus 3x. That quantity squared, and then times 3. Okay? All right, so then if you do that, you're going to be doing 36 times 3, which is 108, 2 plus 3x, and that's going to be to the second power. All right, so let's do the third derivative. So then we do the third derivative. That's going to be 108 times 2, okay, and 108 times 2 is what, 216? Times 2 plus 3x. That quantity now to the first power, and then multiplied by the 3. All right, 3 times 216 is 648. And then this is going to be times 2 plus 3x. Okay, now we can keep going, but I want you to notice that look at what's happening. My exponent for this sum is decreasing. 3, 2, this is technically 1. So you should see that my next one then would just be a constant. Okay, but let's just keep going. All right, so I'm going to have the 1, 2, 3, fourth derivative. So that's going to be 648. Whoopsie. Now that's technically times 2 plus 3x, that quantity to the 0 power, but remember anything to the 0 power is 1, so that's just going to become a 1. And then we multiply by 3. And that's 1944. Okay, now that is the answer. However, that answer choice is not there. Well, we know it's not choice A because we didn't get 0. Okay, and we know it's not choice E because we're not going to get a 2 plus 3x. We get a constant. So it's got to be B, C, or D. Now just try to remember that that 4 with that exclamation point, that's called a factorial. And what that means is 4 times 3 times 2 all the way down to 1. Okay, so then you just work that out. So if you had 5 factorial, it would be 5 times 4 times 3 times 2 times 1. If you had 6 factorial, you would have 6 times 5 times 4 times 3 times 2 times 1. Okay? All right, so anyway, that is 24. And then you just do the rest of the math, and like I said, answer is choice C. All right, the answer for this question is choice D as in dog. So if you got that right and you didn't guess, go on to the next question. So they ask for relative minimum, so I'm going to take the derivative and I'm going to set that equal to 0. Alrighty, so the derivative of f would be f prime of x equals, and I would have 4x cubed minus 16x. Then I'm going to factor out, let's just make my life a little bit easier, 4x, and I'm going to be left with x squared minus 4. So that's going to, and remember I'm setting this equal to 0. So that's going to give me 4x, x plus 2, x minus 2, set equal to 0. Let's t-chart all of this, and I have x equals 0, x equals negative 2, and I have x equals positive 2. All right, so now I'm going to do a sign chart for the derivative. I have 3 values, 3 critical points there, negative 2, 0, and 2. All right, so then you're just going to plug numbers in. So for example, I would plug in negative 3. Now if I were you, I would plug negative 3 into the most factored part of the derivative. It makes it easier. So for example, if I plug in a negative 3 here, I get a negative. If I plug in a negative 3 here, I get a negative. So that's 2 negatives now. And a negative 3 here, I get another negative. So then that means a negative times a negative times a negative is a negative. Okay, then when you get into here, I would plug in like negative 1. So negative 1 in here is negative, negative 1 in here is positive, and negative 1 in here is negative. So a negative times a positive times a negative is a positive. Okay, I know you can do the rest of those. I'm going to end up with a negative here and a positive there. okay, when you plug in numbers. So which makes x equals -2, that's a minimum. X equals 0 is a max. And x equals +2 is a minimum. So let's look at the answer choices here because they want to know which one has a relative minimum. So the answer would be choice D. Okay, the answer to number 6 is also D, as in dog. If I were you, I would totally simplify this before you go and integrate. So I would start by distributing through. So that's going to give me x times x to the 1/2 power. I'll deal with that in a second. And then here, that's going to give me plus 2x to the 1/2 power. Okay, and then obviously dx. All right, so let's look at that x times x to the 1/2 power. So if I look at that, this really, if you want to look at this is really x to the 2/2. And this is x to the 1/2. So remember when you have the same base, you add exponents. So 2/2 plus 1/2, that's going to give me 3/2, right? So then this is going to become x to the 3/2 plus 2x to the 1/2, oops, and then dx. And then I can integrate that. All right, so I'm going to add 1 to it, so that's going to become, what do we got here? X to the 5/2 with a 2/5 in front, right? And then plus, and then I'm going to have x to the 3/2 with a 2/3 in front. But I already have a 2 there, so that's going to give me 4/3, isn't it? Okay, so 4/3. Now remember, that really is 2 times the 2/3. I'm just going to put that there so you can see that. And then plus c. Okay, now let's see. Do we have anything there? Yes, we do. That would be our choice D. All right, this is a super easy question. The answer is choice C, as in chocolate. But I kind of think that you probably thought too much into this. This is definition of the derivative. Limit as h approaches 0. And really, whenever you see this, what they're really asking you for is the derivative of this piece right here, remember? But we ignore the h. So really what they're telling you is that f of x is equal to the absolute value of x. And what's the derivative at 3? That's what they're really asking. Okay? All right, well, listen, we didn't learn how to take the derivative of an absolute value, but what I did tell you to do is when this happens, just always draw a picture of an absolute value. So there's a picture of an absolute value. And at x equals 3, which would be, let's say, out here, derivative is the same thing as the slope. And the slope of this line right here is a +1. Which is then choice C, by the way, which is the answer. If this was a -3 here and they wanted the derivative at -3, well, you would go over here, -3, go up, and you would ask yourself, well, what's the slope of this line? And the slope of that line is a -1. So then your answer would be -1. But since they wanted +3, the slope is positive, so your answer is +1, which is choice C. Okay, you're going to love me on this one. Skip it. No number 8. Let's go on to number 9. Okay, the answer to number 9 is E, the last one right there. Okay, now I just want to talk about this because this is a thinking question. So they're telling you that you have a horizontal asymptote at y equals 7. And it says which of the following must be true. Now I want you to try to remember a definition of a horizontal asymptote, and that's what's hard. It was the limit, if you remember, we talked about end behavior. So it was always the limit as x approaches infinity. Okay, so let me draw a picture, and maybe this will make a little more sense to you. So, okay, you know how I'm going to just back up a second. You know how I said it was always the limit as x approaches infinity? That's definition of a horizontal asymptote. So you could go over here and you could say, oh, well, it can't be choice A because that doesn't approach infinity. It could be choice B because it could be positive or negative infinity. It can't be C and it can't be D either because neither of those approach infinity. So you're down to choice B or you're down to choice E, okay? So let me just show you what I'm talking about though. So they're telling you that you have a horizontal asymptote at y equals 7. So I'm going to go like this, and I'm going to write y equals 7. So there's some function whose horizontal asymptote is y equals 7. So watch, I'm just going to make something up. That would be what the function looks like, right? Maybe, you know, it could look like this, right? Do you see that this has a horizontal asymptote at y equals 7? And so as this picture goes further and further out, closer to infinity, do you see that it's approaching, not touching, but approaching this line y equals 7? And that's what this is saying. As you go to infinity, the picture is approaching 7. That's what this is doing. Okay? But again, I kind of like the cheater method. If you can remember, horizontal asymptote is always as x approaches infinity. It's got to be B or it's got to be E. Now, cheater, they told you that it approaches y equals 7. So it can't be B because that's a negative 7, and E is positive 7. Okay, so if you like that better, then do it that way. Answer is choice E. So for number 10, the answer is B, as in boy. Okay, so we need to know, and we need to remember that instantaneous rate of change, that's just a fancy way of saying F prime. And then average rate of change means f of b minus f of a over b minus a. Now we did that, I think, in sample exam number 1. So it says at how many points in the interval from negative a to positive a does the instantaneous rate of change equal the average rate of change? So I'm going to set those guys equal to each other. Okay, so let's see. We have an interval, and it's from negative a to a. So f of b would really be like saying f of a minus f of negative a over a minus negative a equals, and then I'm going to take the derivative. Now remember, derivative of e to the u is e to the u du. So that would be e to the x squared times, and I'm going to stick a 2x right in front there. Okay? All right, so let's do f of a. So basically, when I'm doing f of a, I'm just putting in an a right here. When I'm doing f of negative a, I'm putting in a negative a right there. All right, so I am going to end up with, let's see, I've got e to the a squared minus e to the, now if I put in a negative a and I square it, isn't that still a squared? Okay, and that's going to be all over 2a, and we're setting this equal to 2x times e to the x squared. All right, well, let's look carefully at what we have here. Look at that. That's 0, isn't it? So that means this entire fraction really is 0. So that means I've got 0 equals 2x times e to the x squared. Now, hopefully you're starting to see something about this. Remember what an e-graph looks like. E-graphs never have zeros. So when we say that this is equal to 0, this portion can't ever be equal to 0 because look, it never touches the x-axis. So what we're going to do is disregard that part because that's never going to be equal to 0. And then really what I'm looking for is where 2x is equal to 0. Okay, and that would be at x equals 0. Now, let's read the question. It says, at how many points does the instantaneous rate of change equal the average rate of change? So then your answer would be choice B, just 1 point. All right, and number 11 is choice B, as in boy. So we've got the mean value theorem here. So that's going to be the derivative is equal to f of 2 minus f of negative 1 all over 2 minus negative 1. All right, so f prime of x, that equals 3x squared, equals, then I'm going to plug in 2 into the original function. That's going to give me 8 minus, now I'm going to plug in negative 1 into the original function. I'm going to get negative 1. The whole thing's over 3. So that gives me 3x squared equals 3. So that means x squared equals 1. And that means x can equal positive or negative 1. However, remember with the mean value theorem, you have to be very careful because I've got 2 possibilities here, but look at my interval. One of my x values here is at the end point of that interval, and you can't have that with mean value theorem, so I'm going to repeat that. If one of your answers is at the end points of this interval, which it is, negative 1, we have to disregard that, and then we just have one value of c. Okay, so then in this case, our answer can only be x equals positive 1, which would be choice B. The answer to number 12 is B as in boy. So they're asking for the area, so I'm going to integrate. And I'm going to integrate from 2 to k. And I'm going to integrate 1 over x dx, which is really an ln, isn't that? So that's going to be the ln of x evaluated from 2 to k. All right, so, oh, and I'm sorry, they tell us that this is going to be equal to the ln of 4, so equals the ln of 4. So let me just get rid of that. All right, so that gives me the ln of k minus the ln of 2 equals the ln of 4. Well, there's a lot of ln's going on here. I don't like that. So do you remember that what you can actually do is we can e everything. I can e this, I can e this, and I can e this. Because remember, e's and ln's cancel each other out. They're inverses of each other. However, be careful, because when you do that, you have to apply all the rules with e's and ln's. So in other words, I see a minus sign. Do you remember that that means division? If this was a plus sign, that means multiplication. So you just can't lose sight of those rules. So I'm not going to have k minus 2. I'm actually going to have k divided by 2 here. Okay, because again, subtraction means division whenever I'm doing e's and ln's. And this is equal to 4, and then we can just cross multiply. So k is equal to 8, and there's your answer, choice B. Alrighty, implicit differentiation here. So the answer is choice C. So if I take the derivative of x, I just get 1. If I take the derivative of y, I get dy dx equals, and I'm going to do a little bit of product rule. So I have the first times the derivative of the second plus the second times the derivative of the first, which is 1, and it's technically dx, but I'm not writing that. Okay, so what do I want to do here? I think I'm going to bring everything with my dy dx's to one side and everything without them to the other. And it doesn't matter which side you go to. So I'm going to leave this dy dx on the left-hand side, and I'm going to bring over the x dy dx, so I'm changing the sign, right? Equals, which means I'm leaving the y, but I'm going to bring over that 1 and make that minus 1. Okay, so I look at the left side, and I say, well, they both have a dy dx, so let me factor that out, and I'm left with 1 minus x. And then remember, to get the dy dx by itself, I'm going to divide out, and there's my answer. So dy dx equals y minus 1 over 1 minus x. Okay, and that is, oh no, I said the answer was choice C, didn't I? Now, never fear, because remember I said to you that this is correct, by the way, but this is a positive y, that's a negative y. This is a negative 1, That's a positive 1. They're opposites of each other, right? Keep going. This is a positive 1. That's a negative 1. This is a negative x. That's a positive x. If all the signs here are the complete opposite of these, it's correct and it's equivalent. Okay? So it doesn't matter. And the reason why that happened was right back up here. I decided to move this to the left-hand side. Had I decided to move this to the right-hand side, I would have gotten this same exact answer. But you're going to have to be able to do this. There's kind of no way that you can foresee that this is going to happen until you get to the end. Okie dokie. And hopefully this one wasn't too difficult for you. It is thinking a little bit differently, but it's just a thinking question. The answer is choice D as in dog. So the reason being is if I look at this right here, I look at that and I say, this is kind of familiar to me. And if I look at that, isn't that really starting out prior to integrating, or if I integrate, isn't that really just f of g of x? Think about what I just wrote. So if I took the derivative of this, it would be f prime of this, and then the derivative of the inside, which is g prime. And that's exactly what I have here. Okay? So again, if I took the derivative of this, I would get f prime of g of x, and then I have to take the derivative of the inside. And that's exactly what I have here. I don't want to leave this out. Technically, this is from 2 to 4. Okay, so then your answer is choice D. For 15, the answer is A. Okay, so they give you a velocity equation, and if you read the second sentence, it says the particle moves upward until it reaches the origin and then moves downward. Now, what that basically is kind of insinuating here is that you have a maximum because you're moving up, then down like that. Okay? All right, so in the original function that would be. So I want to figure out, though, where that point is at. So if this is in the original function, that little picture that I just drew, wouldn't that be where your velocity is equal to 0? So that would be 8 equals 2t, so t would be equal to 4, right? Okay, I want to hang on to that little bit of information for a second here because let's go to the question. I'm coming back to this. So let me just reiterate again that if the particle moves up, then down, that means the original function increases, then decreases. It goes up, then down, which means let's look and see where the velocity is equal to 0. Okay, there's a reason why. We'll come back. All right, so then it says the position of the particle at any time t. So they want us basically to find the position equation, right? Which means I have to integrate my velocity equation, which is 8 minus 2t dt. All right, so if I do that, I get 8t minus t squared plus c. And this would be my position equation, right? All right, well, this is where the t equals 4 comes in because I need to know what c is. So I do know that I have the point 4, 0, right? Here's my 4, there's my 0. So I can plug in that point into my position equation. So 8 times 4 minus 4 squared plus c equals 0. So then that's going to give me 32 minus 16 plus c equals 0. So that's going to give me c equals negative 16. So then my final position equation is going to be 8t minus t squared minus 16. Okay, and I know you have to kind of switch that around a little bit, but the answer is choice A. Okay, it's a good day today. Number 16, skip it. Alrighty, 17, they give you the function and they want to know when it's increasing. The answer is choice D as in dog. If you got that right, skip over to the number 18. Okay, so I'm going to take the derivative because I know whenever I see the word increasing or decreasing, that means derivative. So that gives me 3x squared plus 12x plus 9, and I'm going to set that equal to 0. So I'm going to take out a 3, and that's going to give me x squared plus 4x plus 3. Makes it a little bit easier for you to factor. So that's going to be x plus 1 and x plus 4. I mean x plus 3, what am I saying? And so I have 2 zeros of x equals -1 and x equals -3. So I'm going to do a sign chart for the derivative, and I've got -3 and -1, right? Now you can plug in values, but I do see that my derivative is a parabola pointing upward. So that means that I have plus, minus, plus. And they want to know where the function is increasing. So you can see that the function is increasing here from -infinity to -3. It's also increasing from -1 to positive infinity. Okay, so the answer again would then be choice D. All right, 18, the answer is E. So let's look at this one. We have to integrate, right? So that's going to be 1/2 x to the 4th minus 1/3 kx cubed. K is just a constant, so treat it like a number. And then here we have plus 2kx. And I know I'm going to evaluate that from 0 to 2, right? All right, so let's plug in the 2. And in the first one, that's going to give me 8. In the second one, that's going to give me, 8/3 k plus, that'll be 4k, right? Now, if I plug in 0, by the way, I'm getting nothing, so I'm not going to plug that in. Now, I did purposely overlook the fact that they told me that it was equal to 12. So right now, I'm going to set this equal to 12. Okay? All right, so you can do a couple of things. I am going to move the 8 over to the other side. So that's going to give me, what is that going to give me? 12 minus 8 is 4, right? So I have -8/3 k plus 4k equals 4. All right, so I guess I need a common denominator, don't I? So -8k over 3 plus 12k over 3 equals 4. So then that's going to be 4k over 3, right? Equals 4. Cross multiply, so I have 4k equals 12, and that gives me k equals 3. And there is your answer, choice E. 19, the answer was A. So you're going to have to do a little bit of u substitution here. So I am picking tangent for my u, and the reason being is because its derivative is secant squared. So that gives me secant squared x, right? And let's see. Oh, so that works out pretty nicely. So then that means that this right here is my u squared. And then let me put right here, there, and there. In red, that's my du, right? Okay, so basically what I have is the integral of u squared du, which is 1/3 u cubed plus c, which is 1/3 tan cubed x plus c. Woohoo! Choice A. That was fast and easy, right? Come on. So the answer for number 20 is B as in boy. Okay, now this one's a little tricky. You know that the derivative of ln, because that's what they're asking for, is du over u, right? So then just treat this as your u. Okay, so I'm just going to rewrite that as 1 minus x squared, that quantity to the 1/2. So remember, the formula is du over u. for derivative. Okay, so my du is taking the derivative of what I just wrote in red. So that means I'm going to do 1/2 of 1 minus x squared to the negative 1/2 power, then times the derivative of the inside, which is negative 2x. So there's my du, and that's all over, oh, this is so much fun, right? U, which is 1 minus x squared, that quantity, to the 1/2, or if you prefer, you can write it like this. It doesn't matter. Okay. All right, so let's look at a couple of things here. Well, I can simplify, don't freak out. That's gone and that's gone, right? Now, the other thing I want you to take note of is, isn't this a radical? But in the denominator, because you've got a negative exponent. And if I put this in the denominator, isn't it the same exact radical as what I already have here? Okay, so again, radical one, because I have a 1/2 power, negative brings it down to the denominator. So what I'm going to do is, just watch a sec. So then in the numerator, the only thing I have left is that x. And in the denominator, I'm going to have 1 minus x squared. Now, this 1 minus x squared is coming from this one. Okay, and then I'm going to have another radical 1 minus x squared. And that one, this one right here, is coming from this guy right here. Okay, well, that's silly to write the same thing twice, right? And you should know that a radical times itself is just whatever's underneath the radical, but without the radical. So I don't know if that made sense, but I will show you then. Okay, so, ooh, I forgot the negative here, right? I did. All right, so I've got negative x, and then in the denominator, I'm just going to have 1 minus x squared. Okay, because, again, some radical times itself is just that thing without the radical. And again, this negative that I forgot is that negative right there. I just forgot to bring that down. Okay? All right, now that is the correct answer, but that answer is not there. So we can always take this negative, and instead of having it in the numerator, we can put it down here in the denominator, which would mean that we just have to negate the signs down here, which is not a big deal. Okay, so again, I'm going to move that negative to the bottom, which is going to make that a positive x squared and a negative 1. And then I think that is your answer choice, which is choice B. Okay, the answer for this question is choice C. I kind of think it's a silly question, and I don't know that you really would see it, but I'm going to go with it. It's exponential because let's just say, pick any kind of an exponential. So let's say I have y equals e to the 3x. Okay, so it's talking about its derivative, and it's a constant multiple of itself. So watch. So if I take the derivative, isn't this e to the 3x, then times 3? You see, here's the constant multiple of itself. That's what they're talking about. You could keep going. So let's say you take the second derivative. Okay, so that would be e to the 3x. Then I have to multiply by 3, but I've already got a 3 there, so that would be a 9. So here we go again, constant multiple of itself. And that's why it's choice C. All right, 22, the answer is C. They do talk about concave down, so I'm thinking second derivative, negative. So let's start with the first derivative. So first derivative is 3x squared minus 12x. Let me keep going. Second derivative is 6x minus 12. Set that equal to 0. X is equal to x is equal to positive 2. All right, so y double prime sign chart, 2 it is. Okay, now you can either plug numbers in, or I like to look at this and say, oh, that's a positive sloping line. So negative, positive. But that's totally up to you, whatever works best for you. Negative, positive. And it did say, where is the graph concave down? Well, that would be where your second derivative is negative, which is right in here. So that would be x is less than 2. Okay, and that is choice C. Answer for 23 is D. And they're talking about a cube, and it's increasing at a rate of 0.05 centimeters per second. So that is going to be right here. I don't want to ruin this all, but let's see. Oh, look at how good I was. All right, so that right there is your ds dt, and it's increasing, so it's positive, so that's 0.05. In terms of the side of the cube S, what is the rate of change of the volume? So they're asking you to find dv dt, which means I must be using the volume equation, right? So the volume of a cube is side cubed. So then I need to take the derivative, which is 3s squared ds dt. Okay, now we're looking for dv dt, so I'm just going to carry that down, equals 3. And let's see, did they give us, they did not give us the side, so I'm going to keep that in there, I guess, right? But they did give me ds dt, and that's 0.05. So when I work that out, that's 0.15 s squared. And you can see that that is choice D.